Hello, everyone. Welcome to another Taos webinar. Today's topic of the webinar is or are all different kinds of data preparation tools. Those of you who join these webinars regularly know that the final Thursday of the month is usually the day for Taos to discuss machine translation related topics. And that's exactly how we feel about a topic of data preparation. What is normally said is that garbage in, garbage out. So meaning that if you feed a machine translation engine with poor quality data, it will have a poor quality output. And that is exactly why we are talking about data preparation today. Some of our speakers today are Luisa Bentivogli from FBK, so Fondazione Bruno Kessler, and Marco Turchi, also from Fondazione Bruno Kessler, and our own Amir Kamran from Taos. As always, we have Janice Campbell and Alain Levy from Adobe and Babel, respectively, joining our webinars to steer our panel at the end. Now, this time around, we will do this slightly differently. The topics that we will cover are the data cleaning, data anonymization, and data clustering. And as these are all quite big topics in itself, we will open up questions after each of the topics. I actually forgot to introduce myself. My name is Milica Panic and I will be one of your hosts today. So just before we go into the actual topics, I would like to share a little bit of the housekeeping items. So these webinars and this today is recorded. So for those who couldn't make it today, we will send out a webinar recording already tomorrow. You can ask questions directly through GoToWebinar. There is a nice chat option, and we'll make sure to bring your questions up to the speakers that you address them to. Yeah, this webinar lasts for 1 hour, and I hope you will enjoy it. And now I will tell you a little bit about, well, except for the fact that data preparation are very is a hot topic these days. What is the reason for us to talk about these preparation tools? So for those of you who follow Taos and our news and the developments on the data front by Taos, probably know that as of November this year, well, actually exactly 31st of October, we will be releasing a so-called data marketplace. It is a platform where those who collected the data the language data over time, and when we say data, we mean bilingual text data, and those who need this data to improve their engines can come together and exchange this data. So this has been an idea that's been around for quite a while. And finally, at the end of last year, we got the funding to make it a reality. Now, in order to do that, we work with highly skilled and trusted partners of Taos, one being the FBK and also Translated. So we wanted this data marketplace to really be not just the trading platform for data, but we wanted it to offer value-added services to those who come to use the data marketplace. And some of those value-added services are things like cleaning and anonymization of data. So for those who come to the marketplace to sell data, we offer these services for free. Now, on the other hand, for the data buyers, we also wanted to give them the option to not just search for the data and find data by going through all different kinds of segments or uploaded documents, but to actually get to the tailored data sets for their own specific domain or content type. So for them, we offer what is called a data clustering. So it's a special data selection technique to extract data from large databases based on a sample. Now, all the other sort of features that you see on this screen are sort of very typical for a data place. So the sellers can upload their data. We offer the clean anonymization. They set their price based on smart recommendations, and they get to publish this data. On the other hand, when buyers come to search for data, they get multiple different ways to explore it, to filter their results based on domain, content type, price range, or the sample that I just explained, then purchase, download, and rate and review. This is all very important because we want the data on the data marketplace to be of high quality, and all of these services that we offer actually are there to ensure that. Now, I will hand this over to those who do the real work. First to Marco Turchi from FBK. They have evaluated quite a few tools out there to be able to choose the best ones to do these jobs on the data marketplace. And this is what the core of today's webinar is. So you will be hearing about the evaluation, how it was done, what are the premises for the evaluation, and then we will go into specific tools and what the results of their performances were. So with no further ado, I will make now Marco the presenter so he can go into his part of the presentation, and I hope you will enjoy this.
Okay, so can you see my screen?
Yes.
Okay, so I should be in present. Okay, so thank you, Melissa, for the introduction, and yeah, I will first talk about the overview of the evaluation, and then I will focus on the cleaning, and then I will leave the floor to Luisa and Amir for animation and clustering. So when we start to think about the evaluation, the first step that we need to do is to select the tools. So selecting tools was an important process, and we defined internally to the data marketplace some rules about the selection of the tools. The one is that the tool should be available in the consortium, or the consortium should have the knowledge about the tool that we want to evaluate. As the data marketplace will work on a large number of languages, the tool that we are going to select should be already been tested in several languages and should be open source to facilitate the integration in the data marketplace. Now let's start with the specification of our evaluation. First, we need to decide on what language we want to test our tool. So we decided to use 5 language directions that cover different aspects of the possible language that we have on the floor. So for instance, we want language that are spoken in Europe, and then we want a range of language that move from more to less morphologically rich languages. For this reason, we have, for instance, English, but we have also Czech and Italian. We want to also focus on under-resourced languages. For this, we also include Latvian in the evaluation. In all possible language directions, we have English in the source, but we have also language pair where we don't have English, German, and the pair is German, Italian. The evaluation focuses on 4 different aspects. So initially, we have an intrinsic evaluation, which means that we evaluate the tool in the most classical task. For instance, for the cleaning, the task is to remove the dirty TM from a translation mail. For this kind of evaluation, we need human annotated data. For this reason, we internally to the consortium, we also perform an annotation process. Then the goal of the Chef Data Marketplace is to make available data for training a machine translation system. For this, we want also to evaluate the impact of our tool in the quality of the translation that we can produce at the end. For this reason, we run an extrinsic evaluation, where the goal is to compute the blue score and check how different tools impact on the blue score. An important aspect is also the processing time, because a tool which is super slow cannot integrate in our data marketplace. And the last one is about technical requirement. This, of course, is less scientific, let me say, but it's still important, because if a tool requires a lot of technical component or a particular machine, this can, of course, affect the overall performance of our data marketplace. So let's talk about a bit more about the data. So as I say, for the intrinsic, but also for the intrinsic evaluation, we need human annotated data. For this reason, we run, as I say, an annotation that by professional translator. But we need also a lot of data for training our machine translation system. So in both cases, we ask TAOS to provide the data from its repository. And the data we decide to belong to one single domain to emulate the classic data that we expect to have we receive in the data marketplace. And in particular, we focus on the legal domain. Then the human annotation produces two different test sets. One is around 2,000 translation units for each language. In this case, we focus only annotating with good or bad translation unit, and we didn't consider the domain at all. In the second evaluation campaign, we focus on both aspects, having label about good and bad data, but also focusing on the fact that a translation unit belong or not belong to the legal domain. So this is very brief overview about our evaluation campaign, let me say, and you will find all these aspects in all the evaluation, all the three services. So let's start with the cleaning tools. So the goal of the cleaning is to remove wrong and dirty translation unit from ATM. So the consortium, following the, let me say, the rules that I present in my first slide, we identify three different tools: ByCleaner, TMOP, and Ziffer. So we are aware that, for instance, WNT, there is a task that focuses us on data cleaning. But in this case, let me say, we didn't found one single tool that can contain the new things that are coming for data cleaning. So we decide for the first evaluation to focus on well-established tools that are consolidated. And then in the rest of the project, we can also focus to add in more features based on the outcome of the evaluation campaign that are ongoing at the moment. So the tools that we selected, but in general, the data cleaning tools, they have some common features. So first of all, they extract features from the TM. Then based on this, from the TU, sorry. Then based on this feature, they compute a score that identify a level of goodness. So how good is this TU? Then this will be applied on all the TU inside translation memory. And then a cutoff, a criteria is used to identify what is good and what is bad. Of course, all the tools have this main schema, but they use different features, scores, and criteria. Let's start by ByCleaner. So ByCleaner has a double step. So in the first one, it uses hard-coded rules to identify the most obvious things, a big difference in length, problem in encoding. If a translation unit passes the first step, then it's passed through a classifier that assigns a score between 0 and 1. The features used by the ByCleaner classifier are lexical features and shallow properties. Then once the feature is extracted, they are passed through one algorithm that assigns the score. Several algorithms have been tested in ByCleaner, but in our experimentation, we use the random forest, which is the extreme random forest, that it is the default algorithm. In terms of coverage, so as you can imagine, having a machine learning tool inside to ByCleaner, we need to train it. So at the moment, we have 30 models available. So the 29 has been released with ByCleaner, and then we build a new model for German Italy. The scoring schema is quite simple. Given the ranked TU, is applied a threshold, a value. So if the TU has a score above a value, is good. If it is below the value, the translation unit is marked as bad. TMOP is an unsupervised translation memory cleaning, which is based on the concept of filters. You have 4 big family of filters. Some are basic, so very surface checker, as I say, point to action in the source and the target, different length, and so on and so forth. Then we have a language identifier that, according to the language that has been assigned in the translation memory, it checks that the translation unit is okay with the declared languages. Then we have quality estimation filters that are focused on adequacy, and word embedding filters that look at the semantics between the TU, the source, and the target sentence in the TU. Each of the filters emit an output which is good or bad. So what we have at the end, we have a vector of decision made by the filter that then we need to define a policy that tell if the TU is good or bad. There are different policies implemented in TMOP, and we use the one that results in the better performance in the research paper, which is 20 no, which means that if at least 20% of the filters say that this TM is bad, this TU is bad, this TU is marked as bad. In terms of coverage, is unsupervised, so you can cover any possible language. And here the labeling schema is a bit different. Instead of ranking all the TU inside ATM, is assigned binary score, good or bad, for each TU, of course. Then we have a Zifora, which is very similar to Bicline. So it extracts features, and these features are passed to a logistic regression algorithm that assigns score. So the features are adequacy and fluency feature, which are more in line with the classical machine translation evaluation. And then the algorithm decides if they are good or bad. Similar to Bicline, we need to train the algorithm, and they implement a strategy that, starting from good parallel data, it can train and can discriminate between good and bad translation. In terms of languages, similar again to Bicline, we need to have parallel data in a way that we can train a classifier. The scoring schema is the classic one. We have the score and we assign a threshold to the scores. So let's start with evaluation. So the first one that we perform is an intrinsic evaluation. So what we do, we have a test set, and on this test set we run the 3 tools, and then we compute a metric that comparing the output of the system with the human labels. It's important to remark that the data that we annotated are very unbalanced, because most of the data are good, around 70%. So in terms of evaluation metric, we cannot use the classic one because they tend to reward too much the majority class. So for this reason, we use the balance accuracy, that is the average of the positive class and negative class accuracy. And this metric is much more robust to unbalanced data. Just to give you an example, if you assign everything to one class, the overall score will be 0.5, so which is not super large. So let's start to show the first plot. So as you can see, we start always in the rest of the presentation, focus on English, Italian, and then we present the result also for the other languages, okay? So as you can see here, although the performance between Bicline and TMOP are quite close, Bicline is the best performing system, which is better than TMOP and then Zifora. So if you look at the performance, both of them are very close to, so all of them are very close to 0.5. So we did an deep analysis of the result, and we noticed that the system, all the systems are very good in identifying the good sentences, the good TU, but are quite poor in identifying the bad TUs. So this we investigate as well, and we also contact the human annotator that annotate the data, and what we realized that the bad TU are not really bad, in the sense that the human, of course, mark as bad because, for instance, sometimes in the source you use the word the president, while in the target you have the name of the president. As you can imagine, for a human, this is of course bad because we have a wrong translation on important concept, but it's very difficult to spot for a machine. So this is the reason because our tools are quite some difficulties in labeling the bad ones. When we extend our evaluation to all the languages, as you can see, more or less the performance are comparable. There are some differences, but in general, Bicline is the best performing one in all the languages. An important aspect is the threshold that we use to define what is good and what is bad. So we decide to run all the experiment varying the threshold from 0 to 1, let me see. For doing that, so for biclinear is quite simple because the score is a probability, so between 0 and 1. For Zifora, the score is not normalized, so we use the min-max normalization to convert the score between 0 and 1. For TMOP, that has a binary decision, it's not possible to run this split of the threshold. So by default, we put at the value 0.1 the result that you saw in the previous slide, and these are the This show how on the y-axis you have the balance accuracy, and on the x-axis you have the different threshold that we use. As you can see here, we have better performance for larger threshold, which is 0.7 and 0.8. In this case, what you can see is that also the threshold can change the rank. For instance, if you look in the extreme case at 0.9, the best one became TMOP. And the best threshold depend from the tools. For instance, for bcleaner is 0.7, for Zifora is 0.8. So this is not only the different value of the threshold does not depend only on the tools, but depend also on the data. So in fact, when we extend the evaluation to all the languages, in most of the case, the results are quite coherent for all the language. For instance, if you look at the biclinear, the best threshold is around 0.7 for 3 out of 4 languages, but for German, Italian, the best threshold is 0.5. This may depend probably because the English-German data are less clean, or you have more balanced data between the good and the bad. This suggests us an important aspect. So this means that in the data marketplace, we cannot have a fixed threshold for everything, but it suggests that we need to have a capability to customize our tool and to ask the user to change the threshold. So the idea that we are exploring at the moment is to have 3 values. So we have a very aggressive threshold, a medium, a moderate threshold, and a lenient threshold. So let's look at the findings. So it's obvious that looking at the findings, biclinear seems to be the best performing one, and the threshold has an important role in the evaluation. In the second part, we talk about extrinsic evaluation. So the idea is to run all the 3 tools on the data provided by the trained data provided by TAUS, isolate the good one, train the empty system, and check if there is one system that with its own clean data is able to produce better performance in terms of machine translation quality. Here we have a problem because we look at the TAUS data and we notice that 90% of the data are considered good. So this is difficult if you have 90% of good data to measure the impact of the different cleaning services. And then we have also a problem that we have a problem in budget that's driven, let me say, by the project that we're running. So we cannot work on a so large TM. So we decide to make a selection in a way that we can have a smaller TM using for training the empty system and a more balance between good and bad. The procedure is described in this slide. So we run the tools on the TM, on the full TM, and then we decide to have around 6 million words. And so we select 1/3 of the translation unit from those where at least 2 systems label them with bad. We took 1/3 where at least 2 systems labeled them with good, and then we took 1/3 from the remaining ones. So if the remaining ones are all positive, in the worst case, we have 66% of good and 33 of bad. Of course, this is much more balanced than 19 and 10. Moreover, we decided instead of having only one score to build a kind of learning curve to show how change the performance of the empty system taking more and more dirty data. So what we do, we rank all the data where it's possible according to the score produced by the system, and then we try to threshold, taking 1.2 million word, 2.4, 3.6, and so on. And for each of these partitions, we train a machine translation system and we evaluate on the same test set. The evaluation metric is the classic blue. For TMOP, for which we cannot rank the TUs, we took the good ones and we random sample in a way that we can have 3, 5 different partitions. So this is the learning curve. So what is interesting is to look at position one, because position one includes the cleanest TU according to each tool. As you can see here, that TMOP is slightly better than ByCleaner. When adding all the data, ByCleaner and TMOP are converging to the same score, more or less. And for Zifora, we notice that Zifora has a pre-processing step where it discards the TU if they are too short or too long than a certain threshold. So at the end, without considering the quality. So this means that at the end, we have less data. That's why Zifora has a lower performance than the other two systems. So when extending this evaluation to other languages, as you can see, the performance, the behavior is more or less the same. TMOP is slightly better than ByCleaner. There is the case for English Latvian where they have exactly more or less the same performance, but in general, the results are coherent in all the 5 languages. And TMOP is the best with ByCleaner in the second position. So now let's focus on another important aspect for our evaluation. This second aspect is the processing time. So on average, so what we want to see, how fast are these tools to process our translation unit. So we compute the number of translation units per second that are processed by the system. And we calculate for all the languages and on all the trained data that we select, and then we average all the performance. So what you can see here, although TMOP is the best performing system according to extrinsic evaluation, it is dramatically slow, while ByCleaner seems to be the fastest one. Of course, this completely changed the perception that we have from the extrinsic evaluation, where the best one should be TMOP. In fact, now, if we should consider all the 3 evaluation, the processing time say +1 in favor of ByCleaner. So now, as I said at the beginning, there are other factors that are super important when we want to embed the tools internal to our data marketplace. And these are not, let me say, quantitative analysis or scientific analysis, but are more related to technical requirements. So we decide to analyze 5 different aspects. We check if the tool requires CPU or GPU, that nowadays is an important issue, if they need external resource, or if they need external tools. As we say at the beginning, it's important that we can also customize our tools. So we check if it's possible to change the threshold, and how difficult it is to extend our tool to different languages. At the end, as we want to embed the tool internally to the data marketplace, we need to have the possibility to run each tool on each translation unit. And this means that we don't need to have the whole translation memory to process. So in this very nice and readable table, we can see that all the tools don't need they can run on CPU. So in terms of external resource, ByCleaner and Zifora, they have machine learning tool inside. So they need parallel data to train their classifier. About external tools, TMOP and Zifora, they need some tools for word align and language modeling for Zifora, while ByCleaner seems to be doesn't need anything of them. The more tricky part is the extension to more language. So TMOP, which is say unsupervised, doesn't need anything, while ByCleaner and Zifora, they need parallel data to build additional model. So this is a constraint that we need to consider, because for some language probably we may not enough data for training one of these models. In terms of the threshold, ByCleaner and Zifora allow you to threshold while TMOP no. And it's the same also processing one translation unit. When you process one translation unit, ByCleaner can do it, Zifora no. TMOP cannot, because each filter computes the statistics on the whole translation map. And based on the statistics, decide if this is good or bad. So for this reason, it cannot run, at least this the version we use, cannot work on a single translation. So to recap, no specific hardware is required, and the most tricky part is the addition of new language, in particular for Zifora and ByCleaner. So we arrive at the end of our analysis. So although there is not one tool that achieves the best performance in all the evaluation, ByCleaner result to be the best tool because it's the fastest one in terms of intrinsic evaluation result to in the best performance, and it was second in the extrinsic evaluation, and it can be customized. That for our integration in the data marketplace is a super important aspect. The drawback that we have for this tool is the fact that when we need to add a new language, we need to have parallel data. We hope that this not affect too much our integration, and we hope that we can find enough data for training for all the needed languages. So that's all on the cleaning part.
Yeah, thank you, Marco. Any questions from the audience? I don't see anything yet coming in, but please post your questions during the presentations if you see anything that's of particular interest or have a question that went unanswered. Janice, Alon, anything immediately coming to your mind?
Just one question, maybe one quick question or clarification from me. So it's related to basically how the licensing and the availability of ByCleaner for more general use. It's one thing if Taos adopts it, of course, and applies it within the data market, but if other participants or potential users might want to use it independently on their own data, what's the availability of ByCleaner versus these other tools?
So if in terms of what you mean, in terms of licensing or in terms of resources or models for languages?
In terms of licensing, in terms of ability to use it as open source software or under licensing.
Well, according to our understanding, and I can be wrong because I'm going to go to memory, I think it's open source, so you can use it without too many constraints. But yes, that's why we choose it. In terms of in terms of resources, which is another important thing, I think you have only 29 models available there. So if you want to scale on your own language, you need to train your model.
Mm-hmm. Okay, thank you.
Thank you, Alan.
So we have actually quite a few questions from the audience. There is a question about the format used. I saw TMX, but then a correction for TSV. Do you know? I know that Data Marketplace will be using primarily TMX as a start, yes. But do you happen to know if these tools also use or support TSV format at the moment?
I think they support TSV as well. I'm not sure if all the tools support TMX. So what I know is that they support TSV. I'm not sure if they support also TMX. But honestly, I think that it's quite. There are several converter from TMX to TSV. If you want to use as a standalone tool, as you say, Milica, inside the data marketplace, it will be used the TMX format.
Yes. And another question was whether Taos was using any of these tools to clean the data. Amir, that's a question to you. Currently?
Yeah, so we are using a mix of a lot of things, and ByCleaner is also one of them. But we have a lot of custom written rules as well that we are using. So yeah, it's a mix of a lot of things, and especially for our matching data service, there is kind of a built-in cleaning ability with the matching data algorithm as well. So that's also in place.
Great, thank you. And one final question before we move on to data anonymization is whether we've looked at any tools developed by LSPs, for example. Although I think, Marco, you did mention that there is a scope limitation for this evaluation, but I don't know if you want to add anything.
Yeah, no, well, yeah, we know that there are a lot of tools and valuable tools that we could try, but in this, I think in this evaluation, we focus mainly on something which was open source, and so yeah, that's what this one, as I say, is a limitation given by the project we are running at the moment. So that's why we focus mainly on these open source tools.
Okay, and one very, very final one that just came in, and that's Asian languages. Are they supported right now?
What do you mean, the cleaning? Or
For the cleaning, yeah. So the full question is, do these tools support any language as long as you have some training data? And the example or the are the Asian languages.
So that's a good point. And in the sense that the classifier, I think, can be easily trained if you have parallel data. About biclinear, I think there will be the need of checking the end rules that are set internally, because I think there the concept of number of letter and number of word is not anymore valid probably for other languages. So this will require some extra effort to look at them. But in general, if you want to train the classifier can work. Just the classifier, you have parallel data, you can train your classifier.
Great.
Yeah,
Thank you, Marco.
Can add a little bit, if I can add something more here. So in the marketplace, for all the other languages for which we don't have biclinear models, for example, we are focusing also on the hard rules that are there, and we are adapting that to different languages. So we are adding a lot of tokenizers to find out the length differences, for example, cleaning based on that, and language identification cleaning, for example. So we are adding a lot of hard rules, but in the future we will try to train as many models as possible, and we will add that to the marketplace.
Great. Thank you. Okay, so we'll stop with the questions now. If we have time for any of the unanswered questions, we'll get back to them at the very end. And now over to you, Louisa. I've just made you a presenter, so you should be able to share your screen.
Can you see it?
We can see your home screen. Very nice picture.
I just did what I did before, but this time it didn't work, of course.
Yeah, I think you just have to pull up the presentation. Yes, there we go.
Okay. So here we are. Good evening. So I'm going to present the second service offered to the data sellers of the marketplace, and that is the anonymization service. So the goal of data anonymization is to protect private information which could be contained in the translation memories uploaded to the marketplace. So we do this by detecting what is called personally identifiable information, PII. So PII is any data that could potentially identify a specific individual. Within the marketplace, we decided to address different types of PII, namely person names, emails, URLs, addresses, and different types of numbers like phone, credit card, driver license, identity card, passport number, social security, and license plate. So before going on with the description of the tools that we selected for the evaluation, I would like to discuss a very important issue for anonymization. So the fact is that the need to anonymize PII must be determined in context. Not all PII is sensitive. So if you look at the three sentences presented here, we see that we have names, proper names, addresses, but in the first two sentences, Mrs. Brown kitchen, Pamela Brown, and the addresses, this is not sensitive information because it is publicly shared. There's no need to anonymize it. While in the third sentence, especially, for example, if the sentence comes from a database of patients at a clinic, we see that here the same name, Pamela Brown, and the address is indeed sensitive information. It's private, so it needs to be anonymized. So given this distinction, it's important to understand that our available tools are able to recognize PII in a translation unit, but they do not distinguish between sensitive and non-sensitive information. So they are not able to distinguish what has to be anonymized and what doesn't need to be anonymized. So what do we do inside our marketplace? The translation units containing PII are automatically flagged and notified to the data provider. And then it is the data provider that decides whether the flagged TUs are to be deleted or anonymized in some other way before making them available through the marketplace. Okay, so let's go to the description of the tools that we have selected for evaluation. For person names, we have two widely available, widely known and available tools that are MBERT and Polyglot. So these are tools for the so-called task of named entity recognition. And in this task, the tools have to annotate in the text different types of entities, including not only persons, but also other entities like organizations, locations, facility, and so on. Of course, we focus on person names. All the other PII is dealt with one specific tool, which is the translated anonymizer, a tool created by one of our partners, Translated. So let's see the person names. The first tool is MBERT. This tool is based on BERT, which is, as I said, a very famous and used in the community language representation model, built with deep bidirectional transformers. In this case, we use multilingual BERT, which is a single pre-trained language model for 104 languages. Then, on top of this pre-trained single language model, we add a fine-tuning layer to make it customized for the task of named entity recognition. And to do this, we used a data set, an English data set, which was manually annotated with entities, with named entities. This data set is the English Ontonode corpus, and it includes 19 entity types, but of course we are interested in person names. The languages covered are 104 because the multilingual model, the multilingual BERT, includes 104 languages and performs the so-called zero-shot annotation. So the named entity annotation task is learned on English data and then transferred to other languages. So we can use the tool as it is, trained on English, and evaluate it and use it on other languages. The second tool is Polyglot. This is also a language-independent named entity recognition and recognizer. And this is based on a different technology and choices. So it's based on word embeddings, which are used to encode semantic and syntactic features of words. And then the tool creates, automatically creates a data set with a named entity automatically annotated. To do this, it uses Wikipedia links and Freebase attributes. The links in Wikipedia and the metadata present in Freebase allow to understand if a Wikipedia page deals with a person, and the person name contained in the link or in the attribute is used to annotate the Wikipedia pages. So in that way, for the different languages, we have automatically annotated data that are used to train the named entity recognition system. Currently, the Polyglot covers 40 languages. For the evaluation, we could easily rely on gold standards for named entity recognition evaluation, which are publicly available, and we found them for all the languages involved in the evaluation. And of course, these are named entity recognition data sets, but we carried out the evaluation focusing on person names. And these are the results. We can see that MBERT outperforms Polyglot in all the languages. And also we found out that MBERT is able to find more person names than Polyglot. And this is important because, you know, anonymization is a very delicate topic. So the more entities you can find, the better it is. The second evaluation criterion is processing time. As you can see here, the situation is opposite. In fact, Polyglot is much faster than MBERT. And we also tried to run MBERT not only with a CPU, but also with one GPU, but this didn't change the average processing time. As regards technical requirements, we can see here that there are no particular differences between the two tools. They don't require external resources or external tools, and they are both able to process one TU at a time. As regards the extension to more languages, well, MBERT already deals with 104 languages, so the coverage is really high. Of course, it's possible, provided that you have training and fine-tuning data to train the system. As regards Polyglot, it is not clearly understandable from the documentation. In principle, yes, but of course, it is necessary to replicate all their procedure and use all their resources for other additional languages. Moreover, it is very easy to use these tools because to call them, just few lines of Python are required. So within the marketplace, we decided to choose MBERT, which is better than Polyglot in performance and language coverage, although it is worse in processing time. Okay, a brief description of the other PAI. This is actually a work in progress. So for translating, as I said, URL, emails, and these different types of number, we can use, we found we could use the translated anonymizer. This is a proprietary tool that was made available to the marketplace. It is based on regular expressions and language-specific keywords. First, the language-specific keywords are used to identify those TUs containing the targeted PII. And then the regular expressions are able to detect the PII format of most countries in the world. So the anonymizer works on both monolingual and parallel corpora and is extensible to any language. Of course, it needs that the configuration file is modified by adding the keywords translation, but there are not so many keywords in this file. So we didn't carry out evaluation up to now, but we carried out a preliminary investigation which gave us interesting information. So first of all, there are no gold standards available for these types of PII, so we couldn't find anything. So we ran our tool on TAO's training data. We could see that the tool is very fast because it's able to process more than 5,000 TUs per second. And in the table, you can see the entities, the PII annotated by the tool. And here you can see that we have a problem because some entities like credit card or driver's license or license plate are not present in the dataset. We also annotated with the tool Paracrawl, and we couldn't find these types of entity, which is quite understandable because these are public data. As a matter of fact, almost all public data. So the next step is to take a sample of these annotated entities and to carry out an a posteriori evaluation to understand the quality of the tool. And so this concludes my presentation. Thank you.
Yes, thank you, Luisa. There are already quite a few questions. So one is very much related to how we will actually, how the anonymized segments will be treated within the marketplace. So what will be the choice for the user? Will they be, will we suggest them to delete translation unit, or will we replace it with a variable? So in case of a personal name, will we then say Mr. or Mrs. Smith, or what is that?
Yes, up to now, the options within the marketplace are two. So the user, the data provider, can decide to delete the whole translation unit, or can decide to have it replaced with a placeholder. So up to now, it's like that.
Thank you. And there is.
Anybody
Sorry,
ask a
yes,
question?
go
Okay.
on, Janice. Absolutely, yes.
Yeah, it's more a broader question, so it's not really that technical. So as laws and policies change around the world, you know, we've had to deal with PII, and that's really critical. And I'm wondering, and maybe this is just way out there, is, you know, what about bias in data? You know, that's becoming a really hot topic, and, you know, not necessarily easily identifiable, but I'm just wondering if there's thoughts about that for the future, of just thinking about how to identify and potentially remove any type of bias that we're now, I know there are going to be laws about this coming up, so, well, already policies are changing about that. So what do you think?
Yes, of course, the problem of the accuracy of these tools is is a big problem. We have relaxed the concept of person name recognition, and if the tool finds also, for example, a piece of the occurrence of this personal information, the whole TU is flagged and returned to the user, because the final decision must be left to the user. Of course, yes, this is not a solved problem, absolutely. And as a service, we have to make it clear that everything that is possible with automatic tools will be done, but this doesn't resolve the problem, absolutely.
I don't really mean like mathematical bias. I mean more like social bias. So this is kind of the new topic right now about things like changing whitelist and blacklist, and then talking about, you know, how do we deal with, you know, data that's showing some kind of bias towards certain social or ethnic groups and things like that. So I know it's maybe a little too soon for that topic, but I'm just wondering if you're forward thinking about that, because I can already see that in our corporations, in our society, this is becoming a really important topic. And
Yeah.
that's all. Just a thought.
Well, as researchers, we are dealing with it. We are working on it, and yes, and we know that it's a really hot topic. And there could be ways to reduce this bias by applying the correct anonymization mechanisms. But within the data marketplace, I don't know if we are dealing with this. I don't think so. Maybe.
Well, not right now. I think it's also because of the scope of the project itself and the sort of the approaching launch. But as Amir mentioned earlier, these tools have been evaluated to find the best one out of the open source ones, but they will continuously be upgraded and worked on as part of the data marketplace. So yeah, Janice, I think your question is still to be answered in the future.
Can I answer? Can I add? Can I add a few
yes.
things? Yeah, we know what is the main problem in this case is that if you want to find a tool that is able to define the bias, you need to have the data without bias, because otherwise the tool will have the bias. So yeah, it's not topic as Luisa said, and it's interesting from the research point of view, but it's not easy to solve.
And also it's also even more complex, because it has been shown that also trying to debias the data is not enough to debias the machine translation systems. So experiments have been done, and also with the bias, the word embeddings, the community is trying different solutions to the bias data, or representation of the data, but it's not enough. There are other bias that remain in the data. So it's really important, and it's really important and really difficult, and it has to be tackled from very different perspectives and very different communities, not only the machine translation community.
Exactly. Okay, over to Amir. Amir, very. I sort of hope that you can fit into this remaining 5 minutes. It might be a little bit quick, but yeah, some of our audience might know the clustering tools as the Taos matching data. So, yeah, please.
Yeah. So yeah, I will try to be quick. So my job is to present the clustering tools, but if you see in the slide, it's more about data selection. So why is that? Because the idea is to add functionality in the marketplace such that any buyer can provide a query sample, and then they can select data that is more similar to that query from the bigger repository or from all the data that is available or that will be available in the marketplace. So why these selection tools is related to clustering? Because we think that over the time when lots and lots of queries will be there, then we will be able to tag different segments at the segment level, different domains. Or we can actually make sure that the confidence level of the selected domains are higher based on the various queries that will be there in the future. That's why we believe that these selection tools will eventually create proper domains within the data, which was not really provided as a metadata by the seller. So that's the idea, and we are a little bit biased towards the tool that we built in-house, which is called Taos Matching Data, which we are promoting from last 1.5 year, and it produces some very good results as well. But for this project, we really wanted to test it with some of the other approaches. So we tried to test it with the classical language modeling approach, which is more Lewis selection strategy. And this basically what the idea is to train in-domain language model and then a contrasting language model from the mix of the domains or random data. And then we find out a cross entropy model that scores each sentence. And then you can sort the sentences, and that can give you a selection that is close to your query. For the matching data, the main algorithm is based on information retrieval principles, but then we enhanced the scoring function with some of the language modeling features and some of the domain-based features that gives us better results. So the idea is to index all the data that is available in the whole data repository, and then based on the query, each sentence can give us some sentences back, and then we can merge that together to form selected data sets. So we did three kinds of evaluation. One is extrinsic, which is basically empty evaluation, and then we tried also a recall-based test, and also based on language model, we did evaluation based on perplexity. Um, um, so the setting here was that our query corpus, which was basically coming from, as Marco said, that we created a data set with human evaluation. So we used that data set. It's about 600 sentences for each language pair. And for the clustering, we used the whole data cloud database, which is basically the Taos data which we collected over the last 10 years. So we have a lot of data for each of the language pairs, and then we ran these algorithms to retrieve data sets that are close to the query corpus. And this query corpus becomes also our test set for the evaluation. So here, exactly what what I explained. So the results are that again here I'm presenting in English Italian results, and matching data score the highest in terms of blue. More Lewis is on the second number, but we also match these evaluated these scores against a random selection to just verify that you cannot train a language specific domain specific model just by selecting random data. So and this result is consistent across all the language pairs, that matching data is consistently scoring better for machine translation evaluation. Also, we did the other test, which is based on the exact matches, whether any of these algorithms can return exact matches or not. And because matching data is based on information retrieval, so that was really a predictable score that matching data is able to retrieve exact matches, while more Lewis was unable to give all the results back. And again, this was consistent across the languages. Finally, we did evaluate based on the perplexity. So we wanted to test whether the QD is exactly very close to the selected data set. And this is also matching data comes out on top, and the data, the language model that we trained is very close to our QD corpus. We will going to use this matching data tool in our marketplace as it comes out best in the evaluation as well. The idea is to add two kinds of searching capabilities. One will be just a normal browsing through the whole marketplace, but the second searching capability will be based on this matching data algorithm, where anyone can provide a query sample and then they can run the selection algorithm, and that will give you back very similar sentences to the query, and then you can actually download that customized data set as a document from the marketplace. Yeah, over to you, Melissa.
Yes, thank you, Amir. We're already over time, so Amir, I'll let you click through the remaining few slides so that we don't have to switch between screens. But in summary, Amir, could you click present? You're still presenting? Yeah. So in summary, the tools that are chosen to be integrated into the data marketplace for cleaning are ByCleaner. For anonymization tools is for person names Ambert, and for the other PIIs, the evaluation is yet to be finalized. Whereas for clustering, we will be using the Taos matching data algorithm. Can you move on to the next slide, please? And finally, the reminder of how these services will be presented in the data marketplace. They will be free to all of those who sell and buy data on the data marketplace. For the sellers, those are the cleaning anonymization. For clustering, clustering is for the buyers. So yeah, I invite you all to follow our news and join us for the launch of the data marketplace at the end of October. And again, these tools will be further optimized on the data marketplace as we develop it. What's coming up next from Taos is a continuation on the topic of data, but more on the business side, whether there is a market for language data and how that fits in the current industry landscape. And then again, we'll have a Taos Data Summit, a virtual one on the 10th and 11th of October, of November. So if you are interested to see the data marketplace in action, do join this specific event. Yes. So with this, I would like to thank you, and I would like to apologize for going over time and for all the questions that got unanswered. What we'll do is extract the questions and share it with the speakers so they don't go unanswered. Well, thank you very much once again for attending this webinar. I hope you enjoyed it, and hope to see you next time. And big thanks to our speakers.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.